For our first method of factoring, we're going to look at pulling out the greatest common factor. One thing I want you to make a note of up in this bubble is that typically when we factor anything, we always want to look for the GCF first. What pulling out a greatest common factor can do is take an expression and make it look a lot simpler. And so when pulling out the greatest common factor, our first step is we want to find the greatest common factor between the coefficients. Next, what we're going to do is we're going to look at the variables and find the greatest common factor for our variables. After that, once you've identified what your greatest common factor is, so looking at example 1, for instance, our greatest common factor would end up being 11, because you look at 1, 10, and 77, and 11 is the largest number that goes into both evenly. X squared and x cubed, x squared goes into both evenly. So once you have your greatest common factor, essentially what you're going to do is undo the distributive property. And so we're going to divide each term by the greatest common factor, by that GCF. So 110 divided by 11 would end up giving us 10. X cubed, I'm going to take away that equal sign quick, and then x cubed divided by x squared will give us an x. 77 divided by 11 is 7. And x squared divided by x squared will cancel and get 1. Now, we can't just rewrite an expression by dividing by the greatest common factor because we've now changed that expression completely. To finish out factoring by the greatest common factor, we have to make sure that we write it then in factored form afterwards. So from here, we need to make sure that that greatest common factor is left out front. Essentially, what we just did is the opposite of the distributive property. If I were to multiply 11x squared times 10x, we'd get 110x cubed. 11x squared times 7, we'd get 77x squared. So just make sure after you've divided each term by that GCF, you leave that greatest common factor out front. So with our next example, looking at the 6x to the 7th minus 216x to the 5th, our greatest common factor here between a 6 and a 216 is 6. Between x to the 5th and x to the 7th, you will end up getting x to the 5th. That's what we will pull out of both terms, which is basically what we'll divide both terms by. Here the 6's will end up canceling to become a 1. X to the 7th over x to the 5th would give us x squared. Negative 216 divided by 6 would give us a negative 36. Also note that the x to the 5th would completely cancel and give us a 1. I would put a star by example number 4. It's fine as it is right now as we're working with greatest common factor. Technically, this can factor further. That's the type of problem that we'll take a look at later. For example number 2, I'm kind of going all over the place. We have 4 terms, and if you look at each of them, our greatest common factor will end up being a 3. So we can pull a 3 out of each of them. We will be left with 5x to the 4th minus 4x squared plus 2x minus 12. Our example 5, I'm just moving left to right here. A 12, a 7, and a negative 13 don't have any factors in common. Looking at the variables, we see x's and y's this time. However, the most that all of them have are x's, and the most x's is x squared. So we can go through and pull an x squared out of each. With our first term, we'll be left with 12x to the 3rd, y to the 3rd. Right here, we wipe out all of our x's, so we are left with 7y to the 5th. And then our last one, we had 15 x's, so from here, we are left with 13x to the 13th. Last two examples. Example 3, the greatest common factor ends up being 2x cubed. We can pull that out of every single term. Our first one is left with an x squared. Our second term is left with a negative 12x. And our last term is a 20. Not sure why that drew a triangle, just ignore that. But also please put a star by example 3. That's another one that could be factored further, but for now we can just leave it. Example 6 has a lot going on. We have coefficients, we have x's, we have y's, and we have z's. Looking at our coefficients, our greatest common factor is only a 3. We have x to the 15th, x to the 7th, x to the 8th, and x to the 4th. The most x's that they all have is 4. We have y to the 8th, y to the 15th, y squared, and y cubed. The most they have is y squared. And then looking at our z's, z to the 6th, z to the 3rd, z to the 10th, and z. So the most they all have is a z. That's our greatest common factor. So we can pull that out front. Now, here comes the long part. We divide each of those 4 terms by our greatest common factor. We will be left with 6x to the 11th, y to the 6th, z to the 5th, minus 4x to the 3rd, y to the 13th, z squared, plus x to the 4th, z to the 9th, and lastly, we have a negative 5y. And that is it for greatest common factor.